This video is about doing a little bit of music analysis in R using the tidyverse framework and the tabr library. So let's get started. Remember to clear your workspace and then load in the tidyverse library and the tabr library, T-A-B-R. Okay, that transpose warning is harmless, but will actually be important a little bit later because transposing in music has a different meaning than it does for data frames. Okay, well, the point of the tabr is that it can represent music. In particular, it can represent notes. There are lots of notes that you might imagine. Tabr uses the Western music notation, so the notes are A through G, A, B, C, D, E, F, G, and there are some sharps and flats in there as well. Tabr represents notes and music by way of objects in R and makes it convenient for you to represent them using R strings. So for instance, the string that contains letters that are notes, well, they can be used as notes. You can check if you've got a note by saying is note. So for instance, is B a note? Yes, it is. Is Z a note? No, it is not. However, there is one additional note that's out there, the rest, R. The little r is used as a rest. That is a period of silence. Sounds pretty decent, okay? What about if I have multiple notes played at once? Well, if you string together a bunch of notes, that makes a chord. Is that a note? Nope, it's not a note, but is it a chord? Yup, it's a chord. Sounds reasonable enough. What if I have a little piece of music? For instance, something like this. This is putting spaces, delimits time. So these are separate notes played one after the other. B, then A, then G, followed by a period of silence, a rest. B, A, G, and then another rest. Are those chords? They are not, but are they notes? Indeed, they're all notes. Sounds pretty reasonable. And so you can then ask, all right, maybe I throw in a chord in there. Again, are they notes? All of them except the last are. Is it a chord? Well, the last one is. Sounds pretty decent. Well, in tabr, strings that can represent the pitches of notes are called noteworthy strings. So let's store in a noteworthy string a sequence of notes. I think I've counted that right. Indeed, I think I have. Okay. So, all right. If you know how to read music, this describes a familiar, potentially, piece of music. In particular, it defines this piece of music, which is the traditional children's tune Hot Cross Buns. Okay, so that particular piece of music sounds pretty reasonable. It sounds pretty reasonable and familiar because it's in a particular key. You can check to see whether a particular string, a noteworthy string, like NW string, is in a particular key or not, using the is diatonic function. Drop that string in there and propose a key. I propose that this is in the key of C major. Tabr uses the letter C to refer to a C major. Is it? All of those notes are consistent with being in the key of C major. The rests get NAs, because silence is not in any particular key. It's entirely possible that this could be in other keys as well. The same notes appear in the A minor key. AM is for the A minor. So this is a little bit simplistic. You can't completely and conclusively identify a key, but you can at least make a pass at whether something is not in a given key this way. You'd like to aggregate these presumably, so you get a single true. Well, how do you do that? Well, the all function will do that for you quite nicely. Oops, the NA. How do you fix that? Well, you fix that with an option, na.rm, and you say true, in which case it disposes of the NAs wherever it runs into them. Now I can check to see, hey, is this in the key of F? Nope. Very likely not in the key of F. If you want to know what all the keys that tabr knows about, the keys function will tell it to you. You can certainly read more in the documentation if you're interested. Okay. Well, it's helpful to dig apart these strings a bit and look at them not as strings, but as data frames. So we can turn our noteworthy string into a data frame using the asMusicDF. All right, let's take a look at that. Here's the same song, the B-A-G-R, B-A-G-R, Hot Cross Buns, written out now as a data frame. You can see that there's the pitches. They're represented several different ways. The distinction between pitch and note is that note doesn't keep track of the octaves that are being used. The pitch does. The semitones are a numerical representation of the pitch. Also keeping track of the octave we're in the third octave, which is the octave that contains middle C, the sound frequency in hertz, and it also tells you the pitch interval between one note to the next. So all of this information is now there. This is a nice, convenient, tidy data frame, and you can go ahead and print out a plot, like a piano roll. So you can pipe this right into ggplot. However, if I want to go do that, before I do that, I need like a time column. So that I get a piano roll. In this particular case, each row is a separate note. So let's add that. You can just add that with a mutate. All right, now I've got an N column for my note number. Great. Let's plot the frequency, and let's label them with pitches. All right, got that set up. You could use various geoms to plot this. I'd suggest geom text, which is why I did the label, so that it places the notes where they belong. And there they are. There's the B, the high note, then the A, then the low note. And you can hear this. Here's the B. That all seems to make some good sense. Okay, now, as far as octaves are concerned, how do you manage that? Well, presumably, if I want to cross octaves, I have to go all the way down, all the way up. Well, you can keep track of the octaves you want to use by putting numbers specifying the octaves after each note. Something like this. If I go ahead and plot this, I can just string it together with a bunch of pipes. Like so. Oops, I just overwrote my... I wanted that. All right, let's plot my octaves here. W string 2. ggplot. Remembering to add the time information. Just as before. Something like this. And I did it wrong. This was supposed to be as music df. There we go. Okay, and you can see that I'm going over a variety of octaves now as I'm typing this out. Fair enough. It's straightforward enough to correct for these and change them and adjust them however you like, so you can be in any octave you might want. It's natural enough to think about chords. Well, all right, let's make a piece of music with some chords. Like so. This is now a piece of music with chords, and I can go ahead and do the same kind of plot right off. And you will notice that there is, all of these notes have gotten given the same frequency. Of course, that doesn't make a whole heck of a lot of sense. This is a fault of the as music DF. Well, that's perhaps just as well, because in fact, here's what it would look like in music notation. It looks like this, and if you're a musician, you probably are cringing at this point. If you're not a musician, well, I'll show you why you should be cringing. Yeah, that sounded pretty awful, didn't it? Okay, but never minding the actual plotting of this and playing of it and saying that wasn't a good choice of chords, certainly that information is represented in some form, is it not? And the answer, the answer is yes, it is. What do we get for the C, E, G? We get the root note of this particular chord played here. That's why you only see one here. But the fact is it's tracked in the name of the note, or name of the set of notes shows up in the data frame. So you can see that, yeah, this is going to be a chord. All right, now one thing that you can do with music is you can play in different keys, put it into a different key. One easy way to do that is to use the transpose function. This is the source of that warning that we saw earlier. Just a quick note, the transpose, as you can see, shows up as a tabr function, so it is indeed shadowing the tidyverse transpose. If you need the tidyverse transpose, you'll have to ask for it specifically. Here, this is what we wanted. You tell it the number of semitones, or half steps to transpose. Let's transpose up 3 half steps. If we do that, it gives you a new string, and you can see that these notes are no longer the same notes we had before. The rests are the same, fair enough. What does that sound like? Instead of what we had before. You hear the difference? So transposing changes the key of that particular piece of music. Okay, well, we could certainly ask, what key is it in now? Well, if I've transposed this, I can ask, is it still in the key of C? Well, it probably isn't. Let's check. And we'll go ahead and use the all. Is it still in the key of C? No, it is not. It's in some other key. Well, certainly we could go through and ask, what key is it in now? How do you do that? Well, you loop over all the different keys. You could certainly do this with a plain old for loop, but in fact it's kind of cool to use an R function that does that by way of vectorizing, so it does it all at once. We have to do a few steps in order to make this happen. Just to keep things convenient and save on typing, let's save the transposed string in a new table, or a new variable. It's not a table. In particular, let's just copy this guy right here. So we've got track of that. One thing we're going to need is we're going to need a list of keys. Let's store that in a table too. So if I go ahead and load this My tab, this is the listing of all of the keys. Okay. We're going to use that to process everything that we need. Now, we'd like to know whether or not each key might be the right key for that piece of music. So how do we do that? Well, the way to do this is by way of a rather complicated command. The way to do it is the following. Let's take our table as our list of keys, and let's add to it a flag that says whether or not, a new column that's a flag that says whether or not our piece of music is in the key in question. Now, the way to do this is we need to apply this to every possible, or apply each key to each piece of music. What do we want to run? Well, ideally, what we'd like to say is something like, we want to run is diatonic on it. We want to run is diatonic of what? Well, ideally, we'd like to run this guy on it. And we want to say key is equal to whatever the key is in question. Something like key equals key. This does not work. And the reason why it doesn't work is because is diatonic is not vectorized out of the box. In particular, what we need to do is we need to fix that. And helpfully, there's a tidyverse command called map that allows you to vectorize something that isn't vectorized out of the box. So the way we're going to do that is we're going to say, well, I want to map all the keys through this is diatonic function. So put in the tilde there. That's not the minus sign, that's the tilde, probably next to your one key on your keyboard, that makes a function temporarily out of this whole string here. And it's going to take a variable. The variables are labeled as .x and .y and all those kinds of things. So .x is going to be the key we're using. Okay. Enough said. Let's run it. And you'll notice it takes a little bit of time. It's not particularly fast, in part because the is diatonic function is not particularly fast. Okay, it's done. Convenient to actually save this, though, so let's do that. And there it is. There's our final results. You can see definitely not in the key of C anymore or G. Could be in the key of F. Could be in the key of B underscore, that's B flat, or possibly E flat. We don't know at this level which it actually is in. We need to look at the music a little more closely to figure that out. Pretty cool. Okay, now finally, tabr can handle the timings. All of these notes are the same length as far as tabr is concerned thus far. It contains just all of that timing information in a different kind of string called the note info string. You could certainly make a note info string for this particular piece of music. The note info strings need to have the same amount of information as the note strings do, the noteworthy strings. If we look at our piece of music here, the hot cross buns, and count them up, you'll find that there are 17 notes. So you can go ahead and ask to turn a string into a note info string for this. So you could say as note info for our hot cross buns by telling it that I want all the notes to be the same length. So for instance, if I wanted a whole bunch of whole notes, I could just type in all these ones, and I'm going to miscount, probably. So a way to fix that is to say, actually, all of them are length 1, which is to say they are whole notes, times 17 of them. 17 times 1 will not work, so this would certainly work well. So you can do this. On the other hand, let's actually change things up a little bit and play the notes a little bit more conveniently. Note info strings track the denominator of the fraction. So whole notes are 1, half notes are 2, quarter notes are 4. So for instance, I can start out by having a bunch of half notes, 4 of them for the intro part. So those should all be longer. Fine, and that gets repeated. And then there's the second part, which is a bit shorter, rather than. Hear the difference? We want them to be shorter, so we'll make them quarter notes. How many are there? Well, there's 4 of them, And then that's followed by another 4 of them. And then finally we can make the end be a bit more dramatic by making it have some whole notes. Okay, very well. And you can combine these guys together using a phrase. And so now this is a musical phrase. It's an object. And certainly we can go ahead and as music df this guy. In fact, as music df automatically phrasifies things, so you don't even need to say it. And let's call this a song. And if I go ahead and view my song, you'll see now that there's a lot going on here. The durations change. They're tracking whether they're half notes, quarter notes, or whole notes. Got all the pitches and everything else. And additionally, you can see there's a lot more information now that we've got timing. Slides and bends and articulations and all sorts of other good things. Ultimately, however, what we've done is we've represented the following sheet music. Now, if you liked the sheet music, as perhaps you might, it's convenient to actually print it out in an automated way. Tabr can actually do this for you. You can take our song and pipe it into what's called a track. This is a MIDI track. Pipe that into a score. And finally pipe that into something called a tab. Call it something.pdf. Give it a time signature. And if you have installed the LilyPond library, which is an open source tool that runs outside of R, a separate entire program from R, that allows you to render sheet music, and in fact it also renders MIDIs as well, that is something that R can interact with through Tabr, and Tabr will automatically call LilyPond for you. So coming back to here, oops, we can say, oops. You can say, go ahead and render it, and it goes ahead and does it, and makes, as you might notice, a PDF, the sheet music you were just looking at, and the MIDI output. Tabr being for tabulature, it actually includes the guitar tabulature as well. It's possible to remove that if you don't like it. Easy enough to do, but it's nice as is. So that at least gets you started on doing a little bit of music building and music analysis using Tabr and the tidyverse in R. Hope you enjoyed it.